Part A says we need to find the empirical formula. To do that, we're going to use the percent mass by composition that's given to us in the problem. We're going to assume that we have 100 grams of sample, so 88.8% of carbon would be 88.8 grams, and then we would also have 11.2 grams of hydrogen. Convert mass to moles using the molar mass of each element. Once you've determined the moles of each atom, you're then going to need to find the lowest whole number ratio by dividing by the smallest mole number. We found the lowest ratio right now. It's 1 carbon to every 1.5 hydrogens, but we need the lowest whole number ratio. So we're going to have to multiply these numbers by 2 to get the hydrogen value to 3, and mole number to 3, and the carbon mole number 2. After finding the lowest whole number ratio, just use those numbers as subscripts to create the empirical formula, C2H3. Part B asks us to solve for the molecular weight. To do that, we're going to use the ideal gas law, PV equals nRT. Knowing that moles is equal to mass over the molar mass, or molecular weight, we can substitute this expression into the ideal gas law. PV equals mass over molecular weight times RT. Rearranging the equations to set it equal to molecular weight, you get this, what is in green. The information that the problem tells us is that the temperature is 31 degrees Celsius, gas is under a pressure of 742 torr. The density of the gas is 2.12 grams per liter. So that tells me that the volume of our system is 1 liter. I'm going to assume it's a liter. And then the mass of the gas would then be 1.12 grams. Universal gas law, or ideal gas law constant, is 0.08206. And the units are atmosphere liters over moles kelvins. Because we're going to have to use this universal gas constant in our expression for the ideal gas law, we're going to have to convert temperature from Celsius to Kelvin and the pressure unit torr to atmospheres. Now that we've converted temperature to Kelvin and pressure to atmospheres, we're going to substitute in these numbers into this expression to calculate the molecular weight. Substituting in the values, calculating, molar mass 54.2 grams per mole. Part C of the problem asks us to determine the molecular formula. To do that, we're going to need the molecular mass and we're going to need the empirical mass. Then we're going to divide those two numbers. So the molecular mass was 54.2, and we calculated that in step B. The empirical formula mass is 27.05, and that was determined by just adding up the individual atomic weights of the atoms. By dividing 54.2 over 27.05, you get 2. Then take that number 2 and multiply it by the empirical formula. So the molecular formula would then be C4H6. Here are 3 potential structures for this compound.